We're doing a very short lesson first. That way, when everyone finishes at different times, you can do the work, okay? So page 76, short lesson, not too complicated. So this is when we are finding the molar mass of an unknown substance, because up till this point, I've been like, find the molar mass of sodium chloride. That's a known substance. Find the molar mass of carbon dioxide. That is a known substance. But here we're going to be finding the molar mass of an unknown substance, and the only thing you really need to know for this is what is the unit for molar mass. Please tell your partner what is the unit molar mass, and we are on page 76. I think it's 76, let me double check. Yes, it is. What is the unit for molar mass? Grams over moles. Okay, grams per mole. That is our molar mass. And it actually says right here, molar mass is grams per mole. So we can use this formula to find molar mass. So you guys have these all worked out here. I'm going to do them over on the side because it's always nice to kind of see how we work through it. Calculate the molar mass of a compound. So there's our unknown compound. If 0.472 moles has a mass of 178 grams. Normally, if you want to find a molar mass, where do you look? Yes, on your periodic table. But we don't have any elements here, yes? There's like nothing. So there's nothing to look up on the periodic table. So if you're given a question like this, then you have to go from the fact that molar mass is equal to, and in fact, I'm going to put in brackets capital M, because maybe you don't want to write it out all the time. Maybe sometimes you want to abbreviate it, is equal to the grams over the moles. And guess what we are given in the question? We're given grams and moles. So all we're going to do is throw them in there. We're going to take our grams, 178 grams, put that on the top. We're going to take our moles, 0.472 moles, and put that on the bottom. And then the only thing left to do is to take our calculator and take 178 and divide by 0.472, and we get 377.119. What do I need to do to make my answer better? I need to do sig figs. So we have 3 sig figs and 3 sig figs. So that's going to then round to 377. And what's the other thing I need? Units. What are my units? I have grams and I have moles. So my unit is grams per mole. And that's it. Pretty nice, yeah? Let's make it a little bit more complicated, but not too much more complicated. Here is another question where, again, we want to find the molar mass. And we're going to calculate it again by taking the Okay. Tested the emergency broadcast system. That was exciting. All right, so we now have, it's still going to be the same formula where we have the mass on the top and we have the grams on the top and the moles on the bottom. But when we go to our question, what we find is that we do have grams, so we can fill that in, 892.6 grams. And now we're like, uh-oh, I don't have moles. What do I have instead? Right now I have molecules. What can I do with molecules? I can turn them into moles, and I can do that by using Avogadro's number. Avogadro's number, okay? So we are going to then take, we want to find the number of moles, and we are starting with 4.399 times 10 to the 24 molecules. Now, I want you to be careful when you choose how you write your conversion factor. What should you be filling in first? Before you put in any numbers, you should put in the units, okay? Before you put in any numbers, you should put in the units because it'll make sure, at least it will help make sure that you don't have things in the wrong place. So what unit should go on the bottom? Molecules. And what unit should go on the top? Moles. And we are using Avogadro's number, which is 6.02 times 10 to the 23. And now you can think to yourself, where does that number go? Does it go with the mole or does it go with the molecule? It goes with the molecule because the 1 goes with the mole. 6.02 times 10 to the 23 molecules in 1 mole. So we do that calculation and we get, so we have 4.399 E24 divided by 6.02 E23 equals 7.307 times 10 to the nothing. There's no times 10 to the anything. It's just 7.3073. And my unit now is the mole. So now I can take this number, my moles, and I can plug it in where I need moles. 7.3073 moles. And now what do I do? What do I do with those two numbers? I ask because every once in a while people get to that point and then they just stop. And I'm like, why did you stop? You need to actually do the division. Okay, so divide by 7.3073 and we get 122.15. And now we need to look at our sig figs. Now I've written a whole bunch of digits here. Are all of these digits significant? No, I actually have to go and look at what I was using in my calculation to find that number. I used 4.399 and I used 6.02. So I had 4 sig figs and I had 3 sig figs. And then this guy here, of course, had 4 sig figs. So my answer should have 3. So that becomes 122 grams per mole. That is method 1. And usually that's the method that people kind of like because it's straightforward. However, method 2 can save you a little bit of space. Molar mass, we're still starting the same way. It's still grams divided by moles. And we still know our grams, so we're going to put that on top, 892.6 grams. But now instead of putting moles on the bottom, I'm actually going to toss my molecules onto the bottom. So I have 4.399 times 10 to the 24 molecules. So this is grams per molecule. And I don't actually want grams per molecule, I want grams per mole. So I'm going to have to cancel. What am I going to have to cancel out? I have to cancel out molecules because I don't want molecules on the bottom, right? So I need to put molecules. Where do I need to put molecules in order to cancel them? If I put them on the bottom, now I have molecules times molecules on the bottom. That's no good. So where do the molecules have to go? They have to go on the top so that the bottom cancels with the top. That's why some people don't like this as much, because sometimes it's kind of like, where are the units going? But it does work. And that means that the moles need to go on the bottom, which is where we wanted them, right? There's our moles and there's our moles. Now, the conversion factor between molecules and moles is what? 6.02 times 10 to the 23. Where does that number go? Does it go with the molecules or does it go with the moles? With the molecules. 6.02 times 10 to the 23 goes with the molecules, and then the 1 goes with the mole. And when we do our calculation, 892.6 times 6.02 times 10 to the 23 divided by 4.399 times 10 to the 24, we will still get 122.15, which we will round to, and in this case it becomes easy to see that we have 3 sig figs, 4 sig figs, 4 sig figs, so we need 3 sig figs. And the only units that we have left are grams and moles. So our unit is grams per mole. And there we are. Okay, so that's going to allow you to do the first one of these. The rest of them are a bit of review. Okay, and now we're going to do the quiz. So dividers up. If you need a periodic table or I don't think you need the table of ions, but if you want one, you're welcome to them. The ions and tables are here. I'll just shut off that light so we have the line view on the way up. You can use your own if you want. Yep, whatever you like.